All right, so get ready, because today we're going to the edge of what we know.
To the edge of the universe.
Yeah, basically, to the limits of our universe.
Yeah.
We're diving into this video essay. Um, it explores this crazy concept called the cosmological horizon.
Mhm.
And it suggests that something like 94% of the galaxies that we can see right now are already permanently out of reach.
Out of our reach.
Yeah, gone forever.
It's a mind-blowing idea, isn't it?
Uh,
Like, we tend to think of the universe as this
I know.
endless expanse, right?
Yeah.
Ripe for exploration. And then this essay is like, hold on a second.
Yeah.
There are some very real boundaries.
Yeah, it's humbling. It is. When I look up at the night sky, it just feels infinite, you know?
Yeah.
All those stars constantly being born and dying.
Right.
A cycle that just seems like it could go on forever.
Yeah, it's a beautiful image, and it's how humans have perceived the cosmos for centuries.
Yeah.
But the reality is a bit more nuanced and surprisingly finite.
Okay.
Did you know that the Milky Way, our own galaxy,
Uh-huh.
only creates about 3 new stars each year?
3. That seems incredibly low.
It is.
Is that because our galaxy is running out of fuel for star formation, or?
That's part of it. The essay explains that 95% of all the stars that will ever exist have
Wow.
already been born.
So we're really living at this, like, unique point
We
in cosmic history.
Yeah.
It's like catching the last act of a grand play.
Yeah, the twilight years
Okay.
of star formation.
Okay, I'm still wrapping my head around this 94%, though.
Yeah.
How are 94% of the galaxies we can see already out of reach?
Yeah.
Like, how is that even possible? I mean, it feels like we're constantly making new discoveries, pushing the boundaries of what we can observe.
Right. And we are, but it's the universe itself that's changing the game.
Okay.
It all boils down to this concept of the expanding universe and something called dark energy. You've heard of the Big Bang, right?
Of course. The ultimate cosmic explosion that set everything in motion.
Right. But immediately after that initial burst, there was a period of extremely rapid expansion called cosmic inflation.
Oh.
Imagine a tiny balloon suddenly inflating to an enormous size.
Oh.
Now, during this cosmic inflation, any minor density differences in the early universe got stretched out on a massive scale,
Right.
creating the seeds for the galaxy clusters we see today.
So those tiny variations became the blueprint for the entire large-scale structure of the universe.
That's right. It's incredible, isn't it?
It is.
But this expansion didn't stop there.
Okay.
It's actually accelerating because of this mysterious force called dark energy.
Dark energy.
Dark energy.
It's one of those concepts that always makes me feel like we're on the verge of unlocking some huge secret about the universe.
I know, it really is.
Yeah.
And this accelerating expansion is what leads to the mind-bending concept of the cosmological horizon.
Okay.
Picture it as a boundary, beyond which galaxies are moving away from us, faster than the speed of light.
Faster than the speed of light. I thought that was supposed to be the ultimate speed limit.
It is. But this is where it gets tricky.
Okay.
The speed of light is the limit for anything moving through space.
Okay.
But space itself can expand at any rate.
Oh, okay.
And that expansion is carrying those distant galaxies away from us.
Ah. So even if we somehow develop spaceships that could travel at the speed of light,
Yeah.
we'd still never be able to catch up to those galaxies that have crossed this cosmological horizon.
Precisely.
They're effectively gone.
They're gone.
Forever.
And that's why that 94% figure is so significant.
Right.
The vast majority of the galaxies we see are already on the other side of that horizon, permanently out of reach.
This is definitely challenging my perception of the universe.
It is. It is.
But wait, if they're out of reach, how can we still see them? Shouldn't they have disappeared from our view?
That's a great question. And it leads us to a truly fascinating aspect of this whole concept.
Okay.
Light takes time to travel, even across the vast distances of space.
Right.
The light we're seeing from those far-off galaxies was actually emitted billions of years ago,
Okay.
back when they were much closer and within reach.
So we're not seeing those galaxies as they are now,
You got it.
but as they were billions of years in the past. So
Yeah.
we're essentially looking at ghosts of their former selves.
It's like looking back in time.
Wow.
We're getting this fleeting glimpse
Yeah.
into the universe's history.
Uh-huh.
But those galaxies, as they exist now, are forever beyond our grasp.
That's both beautiful and a little bit eerie.
It is.
Makes you wonder, what does this mean for the search for life beyond Earth? If most galaxies are already out of reach,
Right.
does that mean we should just focus our efforts on searching for life closer to home?
That's a question a lot of scientists are grappling with.
Right.
It certainly emphasizes the significance of our own local group of galaxies.
Yeah.
At 6%, that's still within reach.
Okay.
But even within that limited space, the distances are still incredibly vast.
Yeah, even getting to the next nearest galaxy seems like an insurmountable challenge with our current technology.
You're right. The essay mentions the Maffei group,
Okay.
which is the closest galaxy group outside of our own local group.
Uh-huh.
To reach it, even traveling at the speed of light would take an astounding 11 million years.
11 million years. That
Mm.
puts things in perspective.
It really does, and it raises some fascinating questions about how we approach space exploration and what's truly possible,
Right?
even for a civilization far more advanced than our own.
Knowing that 94% of the observable universe is already beyond our reach, it makes you wonder if we should redefine what we consider a successful space exploration mission. Maybe instead of focusing on reaching those distant galaxies, we should turn our attention to thoroughly understanding the mysteries and wonders that lie within our own cosmic neighborhood.
I think that's a brilliant insight, and it leads us to a crucial point that this essay highlights:
Yeah.
the importance of our local group.
Okay.
This is the stage for humanity's cosmic future,
Hmm.
and it's far from boring.
Okay.
In fact, it's a dynamic and ever-evolving environment, with its own share of incredible phenomena.
See, that's what I find so exciting about this.
Yeah,
Okay. We may not be able to travel to those distant galaxies, but hey,
right.
we have this whole incredible cluster of galaxies
We do.
right here to explore.
Yeah,
And it's constantly changing, evolving.
absolutely.
We talked about the end of star formation, but I know there are still some pretty dramatic events in store for our local group.
You're absolutely right. One of the most mind-blowing events on the horizon is the eventual collision and merger
Oh, yeah.
of our own Milky Way galaxy with our nearest neighbor, Andromeda.
Oh, wow.
That's where we'll pick things up in the next part of our deep dive.
Okay, I can't wait. So we've established that our local group is kind of like our cosmic backyard. It's
Yeah.
what we've got to work with. It's where our cosmic destiny lies.
It is.
And you mentioned this incredible event that's in store for the Milky Way and Andromeda
Yes.
galactic collision.
Yeah.
What does that actually look like?
Well, first of all, picture this. Two massive, swirling galaxies,
Yeah.
each containing hundreds of billions of stars,
Okay.
slowly approaching each other over billions of years.
Right.
Their gravitational pull gets stronger, their outer edges start to distort, and then bam, the collision begins.
That's quite the image. I imagine it would be chaotic. Would it be like a cosmic car crash with stars smashing into each other?
It's easy to imagine that,
Right.
but the reality is a bit more subtle
Okay.
and thankfully less destructive.
Okay.
Galaxies are mostly empty space,
Right.
so the odds of individual stars colliding are surprisingly low.
Oh, okay.
Instead, think of it more like a cosmic dance,
Okay.
a slow and graceful intertwining of these two immense structures.
Okay, so it's not an instant explosion. It's a drawn-out process of merging and blending.
That's right.
What happens to the stars and gas clouds during this dance?
Yeah.
Do they get flung out into space, or do they settle into some new arrangement?
As the galaxies merge, their gravitational forces will start to reshape them. Stars will be thrown out of their original orbits, spiraling into new paths. Gas clouds will collide, creating shock waves that trigger intense bursts of star formation.
So even though star formation is winding down across the universe, this galactic merger could spark a new era of star birth right here in our local group.
It could.
That's kind of poetic.
It is, isn't it?
Yeah.
It's like the universe reminding us that even as things end, new beginnings are always possible.
Right.
The essay describes the eventual formation of a giant elliptical galaxy,
Okay.
nicknamed Milkdromeda.
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 It sounds both familiar and utterly alien.
Yeah,
What will this new mega galaxy be like? Will it be a hospitable place for life?
that's one of the big questions.
Right.
Elliptical galaxies are known for being relatively quiet and stable
Okay.
compared to spiral galaxies like the Milky Way.
Uh-huh.
They tend to have less gas and dust, which are the raw materials for forming new stars.
So could Milkdromeda end up being a kind of sneller retirement community? With fewer new stars being born, but existing ones living out their long lifespans?
It's a possibility, and the essay raises another intriguing point.
Yeah.
As the universe continues to expand,
Uh-huh.
and those distant galaxies we talked about fade from view,
Right.
the inhabitants of Milkdromeda might only see darkness beyond their own galaxy.
Whoa. They might have no idea about the vastness of the universe,
Right.
the incredible diversity of galaxies that exist beyond their own.
Yeah.
They might think their one giant elliptical galaxy is all there is.
That's a mind-blowing thought, right? It makes you realize how much our perspective on the universe is shaped by our place in time and space.
Yeah.
We happen to live in this era where we can observe both the distant past
Right.
and glimpse the potential future of our local group.
It's a pretty privileged position to be in,
It is.
cosmically speaking.
Yeah.
But I'm also thinking about the implications for future civilizations
Yeah.
that might arise in Milkdromeda.
Right?
Would they be cut off from the knowledge of the wider universe? Would their scientific understanding be limited by what they can observe within their own galaxy?
Those are fascinating questions.
Yeah.
And they touch on the very nature of knowledge and discovery.
Yeah.
It's possible that they might develop entirely different models of the universe based on their limited observations, or perhaps they might find ways to detect the faint whispers of the universe's history,
Okay.
like subtle variations in the cosmic microwave background radiation.
It's like a cosmic detective story waiting to be solved.
It is.
But let's zoom back in to our current time and to our own local group.
Okay.
If Milkdromeda is the eventual outcome, what happens to all those other smaller galaxies that are part of the group?
Yeah.
Do they get swallowed up in the merger, or do they manage to survive in some form?
That's where things get even more complex and fascinating.
Okay.
Our local group isn't just the Milky Way and Andromeda.
Right.
It's a whole bustling neighborhood of dozens of smaller dwarf galaxies.
It's almost like a little ecosystem of galaxies,
It is.
all interacting with each other in complex ways.
Right. But how would they fare during this massive merger?
Some of those dwarf galaxies might be completely absorbed by Milkdromeda.
Okay.
Their stars scattered and becoming part of a larger structure,
Right.
but others might be able to survive, becoming satellite galaxies orbiting the new giant elliptical.
So it's not a guaranteed cosmic annihilation for everyone involved.
It's not.
There might be some survivors who adapt to the new environment.
Exactly, and who knows?
Yeah.
Some of these dwarf galaxies might even play a role in triggering new bursts of star formation as they interact with Milkdromeda, adding their own fuel to the cosmic fire.
This conversation has really highlighted the dynamic and constantly evolving nature of our local group.
It is dynamic.
Even though it's limited in the grand scheme of the universe,
Right.
there's still so much going on, so much yet to be discovered.
Absolutely.
And it makes me wonder if our local group is just one tiny part of a much larger structure,
yeah.
a supercluster.
Yeah. Are there other mega mergers happening out there? Other Milkdromeda-like events reshaping the cosmic landscape?
That's a great question, and it leads us to an even grander perspective on the universe.
Yeah.
Our local group is just one piece of a much larger cosmic puzzle.
That's what I love about these deep dives.
I know, it is fascinating.
We start with one seemingly simple question.
Right.
What are the limits of the universe?
Yeah,
And it opens up a whole chain of interconnected ideas and mysteries.
it does.
So where do we go from here? What other cosmic threads can we pull on to unravel this incredible tapestry of the universe? So we've been talking about these mind-blowing cosmic events,
Yeah.
on a grand scale, expanding universes,
Yeah.
colliding galaxies, the
Right.
formation of Milkdromeda.
Yeah.
But I want to zoom in a little bit.
Okay.
I'm curious about the smaller pieces of this puzzle, the details that make up our local group.
Right?
What can you tell us about those other galaxies, those neighbors that share our little corner of the universe?
It's easy to get lost in the vastness of it all. But the details, you're right, are what make it so fascinating.
Uh-huh.
Our local group is home to a whole menagerie of dwarf galaxies,
Got it.
each with its own unique story to tell.
Dwarf galaxies.
Dwarf galaxies.
They sound kind of adorable.
They do?
Are they like mini versions of the Milky Way with tiny spiral arms and miniature black holes?
Some of them do have similar structures,
Okay.
but on a much smaller scale, and they're incredibly diverse.
Okay.
Some are bursting with new star formation,
Mm.
while others are quiet and ancient with stars that formed billions of years ago.
So it's not just about size.
Right.
It's about their age, their activity, their composition.
Exactly.
What are some of the most interesting dwarf galaxies in our local group? Are there any that stand out as particularly unique or intriguing?
Well, one that comes to mind is the Sagittarius dwarf spheroidal galaxy.
Okay.
It's actually in the process of being torn apart by the Milky Way's gravity.
Wait, so our galaxy is kind of like a cosmic bully?
Kinda.
ripping apart its smaller neighbor.
Yeah. That seems harsh.
It's the nature of gravity.
Okay.
But it's also an incredible opportunity for astronomers
You're right.
to study the dynamics of galactic interactions.
Okay.
As Sagittarius gets pulled apart, its stars are being strewn across the sky,
Huh.
creating these streams of stars that we can actually observe.
So it's like we're watching a slow-motion cosmic collision happening right before our eyes.
It is. It is.
Are there any other dwarf galaxies that are facing a similar fate? Or maybe ones that are managing to hold their own against the Milky Way's pull?
There's another intriguing one called the Large Magellanic Cloud.
Okay.
It's much larger than Sagittarius
Uh,
and actually has its own satellite galaxies.
oh.
It's a bit of a rebel, too.
Okay.
It's moving away from the Milky Way at a pretty good clip,
Hmm.
suggesting it might eventually escape our galaxy's grasp.
So it's not a foregone conclusion that every dwarf galaxy in the local group is destined to be absorbed by Milkdromeda.
Right.
Some might actually manage to escape and continue their journey through the universe on their own. It's possible. And that raises even more questions about the future of our local group.
Yeah.
What will the final structure look like billions of years from now?
Right.
Will it be just one massive elliptical galaxy?
Uh-huh.
Or will there be a few stubborn dwarfs clinging to their independence?
It's so cool.
Yeah.
I love how each question we ask just leads to more questions.
That's true.
It really speaks to the boundless nature of scientific inquiry.
It does.
But going back to these dwarf galaxies,
Okay.
are they just interesting from a scientific standpoint?
Yep.
Or could they hold any practical significance for future civilizations like our descendants who might one day inhabit Milkdromeda?
That's a great question. While dwarf galaxies might not be as glamorous as their larger counterparts,
Right.
they could actually be incredibly valuable
Okay.
for future space explorers.
Okay.
Because they're smaller and less gravitationally bound,
Right.
they could be easier to travel to and explore.
That makes sense. It's like starting with a smaller, more manageable step before attempting a giant leap across intergalactic space.
Exactly.
Are there any dwarf galaxies that might be particularly hospitable to life or that hold resources that could be useful for a spacefaring civilization?
Well, some dwarf galaxies are thought to have vast reserves of hydrogen and helium,
Okay.
which could be used as fuel for starships.
Right.
And who knows?
Yeah.
Some of them might even have planets with conditions suitable for life.
That's an exciting thought. So even though we might not be able to reach those distant galaxies beyond the cosmological horizon,
Right.
there could be entire worlds waiting to be discovered
Yeah,
right here in our own backyard.
exactly. And that brings us back to the key takeaway from this whole deep dive.
Okay.
The universe might be full of limitations,
Uh-huh.
but it's also full of wonder and possibility.
Yeah.
Instead of seeing those limitations as barriers,
Right.
we should see them as invitations to explore more deeply, to appreciate the intricate details and the fascinating stories that unfold, even within the confines of our own cosmic neighborhood.
It's like we've been given this incredible gift, this limited but still incredibly vast and complex region of space to call home.
It is.
And we're only just beginning to understand its richness and its potential.
That's right.
Well, on that note of cosmic curiosity and boundless exploration,
Yeah.
I think it's time to wrap up our deep dive.
Okay.
Thank you for taking us on this incredible journey to the limits of the universe and back.
My pleasure.
It's been a truly thought-provoking experience.
The pleasure was all mine. And remember,
Yes.
the universe is a vast and ever-changing place. Keep looking up, keep asking questions,
Yes.
and never stop exploring.